Hi friends, welcome back to my channel. This is Spandana.K of CSE department studying at Sri Venkateshwara College of Engineering. Today we are going to discuss about the topic that comes under design and analysis of algorithm. The subject code is 21CS42. Now let's get into the topic. The topic that we are going to discuss today is algorithm to perform a sequential search. Topics that we are going to discuss. The first one is what is sequential search? Steps to design an algorithm. Designing an algorithm using a sequential search and time efficiency of the sequential search algorithm. Firstly, let's discuss what is sequential search. Sequential search, which is also known as linear search, it is a simple searching algorithm used to find a specific element within a list or an array. Suppose we have to find a specific element in the list, we use a sequential search. It works by iterating through the element of the list one by one until the desired element is found or the end of the list is reached. Until we find the desired element or until we reach the end of the list, we keep on iterating the elements that are present in the list. At the beginning of the list, compare the target element you are searching for with the current element in the list. We are going to find or search the elements or desired elements by comparing the target value with the current value that is present in the list. If the current element and the target element matches, then the search is successful. It is a straightforward algorithm. Now let's see steps to design an algorithm. The first one is start at the beginning of the list. Compare the target value with the current element. If the target value matches the current element, the search is successful and the position of the element is returned. If the target value does not match the current element, move to the next element in the list. Repeat the steps 2 to 4 until either the target value is found or the end of the list is reached. If the end of the list reached without finding the target value, the search is unsuccessful and not found indication is returned. Now let's design an algorithm for sequential search. This is the algorithm for sequential search as per the steps that we have discussed now. Algorithm sequential search, that is an array of 0 to n minus 1 elements and the k. K is a search key and searches for the given key in an array A. Input, that is array of 0 to n minus 1 elements and one search key. Output returns the index value of the element found, or else it returns -1 if no matching elements. I is equals to 0 while I is lesser than n and A of I is not equal to k. I is incremented and if I is lesser than n returns I or else it returns -1. Let us consider an example for this. These are the elements that are present in the list and A of 0, A of 1, A of 2, A of 3, A of 4 are the index value of these elements that are present in the list. If n is equals to 5 because we have 5 elements in the list. Suppose we have to find 13 in this given list of the elements. So the key value will be 13 for us. As per the algorithm, the search should start or begin from the starting of the element. So starting first element will always have the index value 0. So I will be 0 and again it comes to while loop, that is I is lesser than n and a of I is not equal to k. Here I value is 0 for us and 0 is lesser than 5 because n value is 5. So 0 is lesser than 5 and a of 0 is not equal to 13. This statement is true because a of 0 value is 5. So 5 is not equal to 13. This statement becomes true. And if the statement becomes true, I gets incremented. Suppose initially the I will be at the position 5. If it gets incremented, it goes to the position 10. So the 10 index value is 1. So I becomes 1 here. So 1 is lesser than 5 and A of 1 is not equal to 13. It's true because A of 1 value is 10. So 10 is not equal to 13. The statement is true. So I gets incremented. So I becomes 2. So 2 is lesser than 5 and A of 2 is not equal to 13. It's true because a of 2 value is what? 8 here. So 8 is not equal to 13. So this statement becomes true. Again, I gets incremented, so I becomes 3. So 3 is lesser than 5 and a of 3 is not equal to 13. A of 3 value is 13. So 13 is not equal to 13. No, this statement is false because 13 is equal to 13. This statement becomes false. So if the statement becomes false, it exits from the while loop and it comes to the if condition where the condition is given by I is lesser than n. If this condition becomes true, then it returns I or else it returns -1. So let's see here. I is equals to 3, so 3 is lesser than 5 and a of 3 is not equal to 13. This statement becomes false, so it exits from the while loop and it comes to if condition. If condition is given by I is lesser than n, so I is given by 3 here, so n is given by 5 here, so 3 is lesser than 5. This condition becomes true, so it returns the I value. Here I value is 3, so it returns 3. This is the simple example for sequential search. Let's discuss the time efficiency, that is best, worst and average cases of the sequential search algorithm. The best case is 1, that is T of n is equals to 1 because the search element is present at the position 1 of the list. Then it is easy for us to search the element. So T of n is equals to 1. The worst case is T of n is equals to n because if the search element is present at the last of the list, so it is very difficult to us to search the element. So T of n is equals to n for the worst case. For the average case, we have two probabilities, that is probability of the successful search and probability of unsuccessful search. So we have two probabilities here. So we take p as p is lesser than greater than or equal to 0 and lesser than or equal to 1, and we multiply p by n to 1, p by n into 2, p by n into 3 and so on, n into p by n plus n of 1 minus p. So we take p by n common, so 1 plus 2 plus 3 so on to n plus n of 1 minus p. P by n, 1 plus 2 plus 3 and so on to n can be written as 1, n plus 1 divided by 2 plus n of 1 minus p as it is. So if we substitute p is equals to 1, n into 1 minus p becomes 0 because 1 minus 1 is 0, so it overall term becomes 0. So the average case is n plus 1 divided by 2 because if we substitute p is equals to 1, here p becomes 1, so n plus 1 divided by 2 and this whole term becomes 0. So the average case will be n plus 1 divided by 2. So this is the best, worst and average cases of the sequential search algorithm. Thank you for watching my video. Please do like, share and subscribe my channel.